This video is going to explain how adding or deleting one base pair can result in a truncated non-functional mutant protein. Our normal protein you'll see here is actually longer than our mutant protein you'll see here. The first two amino acids are the same, and then the third and onward is where it starts to change. And we're going to figure out why and basically how to develop our mRNA strand from it. So the first step is to take our amino acids and decode it with this chart here. So we'll take MET, we'll find MET here, that has only one possible codon, AUG, so we can actually go ahead and just write that for both of our strands, the full AUG, because it can't be any other possibility. Next, TRP is the same, again it's just one codon, UGG, so we can go ahead and put those there. Now the third one, the third amino acid is where it starts to change, so we'll do one at a time. So PHE, if you look on our chart, actually has two possible codons. So they're both UU, and then the third base is where it is a possibility of two different letters. So we'll go ahead and put UU and just leave that blank for now. Then we can move on to each amino acid, and basically we're going to do the same thing, and you'll see that it ends up being AC blank, AA blank, GG blank. Then we can go on to our mutant protein and do the same exact thing. So we'll start with ILE. Now you'll see ILE has three possible codons, and they're all AU, and then the third base again is where the possibility can be different. So we'll do the same thing and do AU and leave it blank, and we'll go all the way to the end. Now with the end we actually have a stop codon, and with the stop codon there's a possibility of the second base being two different letters as well. So we'll leave both of those blank for now. Now basically we want to figure out what happened and where it changed and how that worked. So with setting it up like this is really nice because we can kind of see what might have happened and match things up. So you can see AUG and UGG, those are the same amino acids, so those line up fine. Then we have an A and we have a U. Now this is where it changes, and we want to figure out if we've added an A, deleted an A, or the same with the U. So if you look, and if you shift just a little bit, say we added the A, then our letters that are visible and not blank actually will line up. So we've got UU, AA, and then so those two line up, and then we can look at the possibilities of the third base. And as long as those possibilities are in these codons and they match up, then you can basically continue on. So if you look through, you'll see that UU lines up, CC lines up, AA, that makes this C, that makes this U, and it makes both of these A. So you can kind of see the shift that happens, and this is called the frame shift,